welcome to Radical Talks. This is a podcast from Radical Ventures where we explore the AI era. We dig into the innovation happening at the forefront of AI. That's the cutting edge research, the new product paradigms, and of course, the startups building at the frontier. I'm Molly Welch.
I'm Aaron Rosenberg.
We're partners here at Radical, and today we are lucky in that we are exploring one of the most consequential and exciting approaches in modern AI, and that's reinforcement learning, or RL. RL is not new. Reinforcement learning was originally inspired by the ideas of behavioral psychology and the mid-20th century work of researchers like B.F. Skinner in particular, whose research focused on behavioral learning through rewards and consequences. Rich Sutton and Andrew Bardo established the foundations of the field in the machine learning context, starting in the 1970s. And of course, RL was the hero technology of the late 2010s in AI, underlying work like AlphaGo, AlphaZero, and AlphaStar, which we'll talk more about in a moment. But then came, dun dun dun, the transformer and language models. And the field shifted towards self-supervised learning for autoregressive language models. Human data, rather than interaction data, became the primary driver of progress, along, of course, with aggressive scaling. RL was seen as kind of out of fashion. So what happened? Because if you're like me and like us here on this Zoom today, you know that RL is back in a really big way. You may have followed the rise of reasoning models like OpenAI's O1 and O3, and of course, Seek R1. Approaches like RLHF and RLVR are on the tips of everyone's tongues, at least if you are, again, nerds like us here on this podcast today. Aaron and I, again, as massive nerds, have been joking that it's kind of like the Return of the Jedi, and it feels like what's old is new again. So Aaron, I want to turn to you now. Before you were an investor, you had a front row seat to RL's first golden age as head of strategy and operations at DeepMind. How do you think about this new boom for RL?
Yeah, well, thanks, Molly, for having me. It's fun to be here. And you're absolutely right. When I joined DeepMind 8 years ago, it was truly the heyday of deep reinforcement learning. As you said, RL traces its roots back to the mid-20th century, yet the explosion in capabilities really only arrived with the combination of traditional RL algorithms and neural networks of increasing scale. One of the pivotal moments came in 2013 when DeepMind achieved unprecedented performance in the suite of Atari video games. The team had trained a single system to master a range of games like Pong and Space Invaders just by ingesting pixels from the screen and outputting actions. My favorite example is Breakout, the game where you have the paddle on the bottom of the screen that you control and you're trying to hit the ball to break the bricks at the top. And the agent learned to hit the ball in such a way as to get around the bricks and up to the top of the screen and just knock them all out from the top, which is a tactic that humans learn as well, but is fairly sophisticated and just reflected, I thought, a sense of sort of brilliance and ingenuity. And that work, which leveraged a novel approach called Deep Q networks, or DQN, would go on to earn the DeepMind team the cover of Nature magazine, a quite prestigious achievement, and I think one of the first times that they managed to do so. This was then followed by a series of remarkable accomplishments that showcase the power of RL. In 2016, as many listeners will hopefully know, the team created AlphaGo, which beat the world champion Lee Sedol in the complex board game of Go, a feat that was expected to be decades away by most experts. And then in the winter of 2017, shortly after I joined, but certainly by no virtue of my doing, we developed AlphaZero, which became the world's best at Go, chess, and shogi solely through self-play. That is, just by repeatedly playing each respective game, exploring different strategies and tactics through trial and error. Without any human data or supervision, the agent improved to superhuman levels of performance. That same winter, DeepMind created AlphaStar, which became the first AI to defeat a top professional player at the real-time strategy game of StarCraft. As someone who played a lot of StarCraft during my high school years, you mentioned being a nerd at the outset. I certainly was one and still am to this day. This was especially cool for me to see. And I should note that DeepMind made advances not only in games, but also in various real-world settings. Two examples that I think are worth noting. One was a collaboration with YouTube, where DeepMind used DeepRL to improve video compression, reducing the amount of data streamed to users by 4% with no noticeable loss in video quality. And that might not sound like a lot, but given that YouTube alone is responsible for about 20% of global internet traffic, that means that DeepMind's work made the entire internet 1% more efficient, which is pretty wild. And even crazier, perhaps, was DeepMind's application of deep reinforcement learning to nuclear fusion, where the team successfully controlled and shaped the fusion plasma in tokamak, which is the sort of magnetic apparatus for containing fusion. It was amazing. All this is to say that deep reinforcement learning has led to some incredible achievements that have advanced our scientific understanding and benefited humanity. And I mentioned earlier that it was the combination of RL and neural networks of increasing scale that really sparked such progress. Now we have the transformer architecture and large language models, neural networks of gargantuan scale with a huge foundation of general knowledge baked in. So I am all the more excited about this recent resurgence of RL. And just like that prior golden age, as you called it, this one, I think, will rely on a few key ingredients that are very much coming into place. First, we need massive amounts of compute. Many in the industry will or believe that the amount of compute dedicated to RL will soon dwarf what has been necessary for pre-training alone. Who will have access to that capacity and the engineering capabilities that are necessary to make the most of that capacity, which remain super scarce. Second, we need high-fidelity simulators and verifiers. The reason games have been so suitable for RL is that there's a very clear reward signal. You win or you lose. And you can relatively easily play hundreds, thousands, millions of instances of a given game. In tasks relevant for many real-world settings, that reward signal may not be as objective or as proximate, and you may not be able to rerun the task repeatedly without consequence. How can we create training environments that recreate the task at hand with mechanisms for reliably assessing whether the agent has done well or poorly? Third, we need algorithmic innovations. Reinforcement learning is notoriously finicky and relies on methods that stabilize the learning process. I mentioned DeepMind's DQN, which was one such example. Then came OpenAI's PPO, proximal policy optimization, which was critical in training LLMs to learn from human feedback. And then earlier this year, DeepSeek introduced GRPO, which improved performance in complex reasoning like math and coding. What will be the next major algorithm? These are just some of the questions that are on my mind and why I am so excited for this discussion with Ross.
Great way to tee up the discussion. And Ross, I want to now bring you in, and we're so thrilled to have you joining us to unpack this. Thank you for being here. We're really thrilled.
Thank you for having me.
Ross, by way of intro, is co-founder and CEO of General Reasoning, and he previously led the reasoning team at Meta AI during the development of Llama 3 and Llama 2. Ross was also the research lead on the Galactica project and co-founded Papers with Code before its acquisition by Meta. Now he is working to productize a new generation of RL systems through his new venture, General Reasoning, which we are really excited to talk to him about today. So Ross, thank you again for joining us. Let's jump in.
Great.
Hey, Ross. Thanks for being here. You have led some really fascinating research from Llama 2 to 3 to Galactica. Can you share a bit more about your background and the questions that have driven you as a researcher and entrepreneur?
Sure, yeah. So my background is definitely very nonlinear. So there's an old distinction between a fox and a hedgehog. Do you do one thing very well or lots of things? I'm definitely a fox. So I think for me it's always about following my curiosity at each step. So my background was originally kind of statistics and time series. My first job was actually in the UK government, which I didn't like very much because I couldn't build anything. But in my spare time, I was making machine learning models for kind of sports and also making time series libraries for Python. Eventually, I found I could do this for a job. So that's kind of my inroad into ML. And then working for a quant fund on sports betting, that was my kind of real first introduction to okay, how do you make models in this highly competitive setting? So there I kind of learned some very early lessons about, I thought I was going to be doing lots of complicated things, but sometimes a simple thing even works in those kind of settings. But also just learning the ins and outs about, machine learning in that kind of setting. But eventually after that, I wanted to do a startup. Left that, founded a startup which made Papers with Code in London. So Papers with Code, if people aren't aware, used to be this site that was kind of like an early kind of community platform for ML. So if you wanted to find out what the state of the art was, you'd go there and like find these benchmarks. And that went really well, so that kind of blew up quite quickly. We joined forces with Meta late 2019. And then within Meta, we had like, I would say, kind of typical like post-acquisition kind of issues. Our initial roadmap wasn't going to quite fit in. So at the time, our team was like, oh, well, we're in this place, lots of GPUs, great researchers, let's do some kind of research. And the interesting thing there was, I would say, even in like 2020, we were like very optimistic about language models as kind of the future of the web. So I remember at the time we wrote this big piece internally, which we kind of imagined like, the generative web. So we were quite excited about like, okay, if we did the next generation of like Papers with Code, like indexing information, like what would that look like? So that kind of led to like us to move on to Galactica, which is kind of a LLM for science. So yeah, the main achievements with Galactica was essentially at the time like a couple of innovations. So had like on the one hand, it was like a data constrained environment. So how do you make a language model if you're only focused on kind of scientific data? That's actually quite relevant now as we're kind of in a new kind of data constrained regime. But also some early work on reasoning, internal reasoning tokens, also things like multi-epoch training. So it was quite cool aspect. What people will remember about Galactica was the demo, which is fairly notorious at the time, 2 weeks before ChatGPT. I like to say to my friends, kind of like the original sin of generative AI, which is kind of like a big title. But no, I think at the time, maybe it's my gambling background, but it was kind of like a positive expectation bet. We felt we had to do something a bit, risky to try and catch up to OpenAI and get lots of information. So I don't regret that at all. But cut long story short, kind of ChatGPT came out. Then within Meta, there was then finally kind of like a top-down push to do LLMs. And then essentially, Team Galactica, we got brought in to lead the post-training for Llama 2 and then eventually like Llama 3. So I'd say there, kind of in retrospect, in a weird kind of way, my impact, I think, was probably just mostly hiring like the initial like post-training team for Llama 2 in a weird kind of way. And they've gone on to do like amazing things, and I'm quite proud of that. But then certainly what I was focused on was kind of more, okay, what are the main limitations of, LLMs? And at the time, it was thought they couldn't reason, right? So, I distinctly remember we thought we'd need all this complicated stuff. But as a common theme of these stories, we tried something simple PPO at the time on Llama 2, worked really well. But at the time, it was like kind of the first model internally in Meta, which was beating GPT-4, so that kind of surprised us. But that was also interesting as well, in that we didn't get to that kind of O1 moment, right? So that's a very interesting story as well, I think, about how, different priors in RL, like, having the right base model, but also just like, the right data and compute kind of affect your outcome. Anyway, cut a long story short, eventually the publication culture in the Meta changed, and I just wanted to do more things in the open. I'm still a startup person, at heart. So left Meta, explored some like left field things for a while, AI for science, but kind of eventually came home to reasoning, I guess, in the right year in 2025. So yeah, very nonlinear story, but the common theme is just following my curiosity at each step.
That's amazing. The long and winding path.
The long and winding path.
Pretty inspiring. And you've been throughout that period at the vanguard of reasoning models, maybe some of the more immature ones to some of the more mature ones, applying RL to LLMs. And techniques like RLHF have put RL back into the conversation in a significant way. And more recently, approaches like RLVR are attracting attention. Can you put these techniques into context for us and the audience? Can you talk us through how you see the field having evolved and where we might be going next?
Sure, yes, it's a good question. So first of all, I would say I definitely adopted RL. I kind of wasn't born into it with like PhD, but maybe that gives me like a unique take. So for me, I kind of always want to break down the jargon. So I think the fundamental thing about reinforcement learning is that it allows you to optimize the objective you actually care about. So the contrast I'd use for people is if you think about the previous generation of LLMs, it was based upon like imitation learning. So you have all this internet data and you're just trying to essentially match what humans are doing. But if you think about it, that's not the actual thing you care about, right? So if you have, let's say, like a math question, since we're all nerds in the chat, in that case, like, the real objective isn't predicting, the next word. The objective is like whether the answer is right or not, right? And so that's the real promise. And even the examples you mentioned, Aaron, about these kind of games, you have these very like clear outcomes that you're trying to achieve. So that's the real promise of RL. Like, you have the real objective, right, that you want to optimize. The thing about that is, I would say, is like, with LLMs, we hit this point where there are certain problems in kind of reasoning, but hallucination, which in a kind of weird way reflect that problem. So like when GPT-4 came out, it was doing very well on a lot of knowledge-based tasks, but any task where you needed like kind of long, multi-step reasoning, like the outcome wasn't reflected, right? So how do you get the outcome in? Now, so that's essentially what the promise of RL, but RL like has several ingredients. So I'd say the main ingredients are going to be kind of the algorithm, I would say like priors, and then maybe like data or environments, which is like kind of the hot new word in town. So the interesting thing is traditionally I would say like RL is very algorithm focused. So if you think about the 2010s, an example you gave, Aaron, like the general DeepMind approach was that you kind of start from scratch and then like kind of figure it out naturally. So you're trying to get rid of as many priors as you can. You might be able to bootstrap it, but that was a general approach. But that's recently changed, and I would say part of the reason why it's so successful now is you have all this kind of world knowledge in these language models that just allows you to bootstrap RL a lot better, right? So even with these LLMs that were very bad at math, they had the knowledge about math, they didn't have the reliability, right? So RL is kind of connecting those dots. So that's what's kind of algorithms. I would say that is changed a bit, with the advent of LLMs, but not that much. But the big change has been, I would say, the data and then, also the priors. So the priors of the models. And the importance of the priors, I'd say, is just like, there's several cases about this. So the first example is like, I think it's a general consensus that having a really good base model was really important for reasoning to emerge. So like, it's possible if you pushed really hard on like the old like language models, you would have got RL to work, but it really kicked into gear with GPT-4 level models. So there was definitely an aspect which like the players who had a head start there were like in a very good position to exploit that. So that's that. But then even more recently, there's been examples with like, say, Llama 4 projects where decisions about different bits of the architecture actually severely hindered the performance of RL. So like Llama 4, there's several like kind of reasons for why that didn't work out, but it's interesting how tightly coupled that is now. So your RL really depends on like that kind of prior ingredient. And then the final thing is environments, which is the thing that people want to talk about, but we can maybe talk about that in detail. But I would just say, environments are kind of like, how do you get your data, right? So like what's the agent going to interact with? But maybe we can talk about that in like another question.
Oh, we're going to talk about it, Ross. We're absolutely going to talk. We can't do an RL podcast in September 2025 without talking about environment. So don't worry, we will talk about it.
All right.
But this is great. And I really like this framing of both putting RL in context and talking about some of the key ingredients. And you've actually built a lot of these reasoning systems in practice, Ross. Can you talk a little bit more about what they look like technically? What are some of the misconceptions that people have about how they work? And what are some of the limitations today?
Yeah, I think the main thing, at least in the public views, and I see this in other fields as well, is like people like overemphasize the methods and probably underemphasize like the data and the infrastructure for sure. So like, in practice to get these reasoning models to work, you do need like, high quality data and you need enough of it for things to kind of kick into gear. And that's actually certainly something like kind of lacking in the open source field as well. Even now it's a little bit better than it was, but it's still like very, I would say, dominated towards math and code. Whereas the reality is to get things working well, you just need a lot of data. And I think what you'll find is like different labs will have like a different favored RL algorithm. This was even the case in the 2010s. DeepMind would have like an A3C and then OpenAI PPO. Fundamentally, it's sort of doing the same thing. And I would actually say that's like probably less important than probably your general like setup. The second thing is just infrastructure. Like infrastructure is like very important for RL. RL is like very, very expensive. That is also links to that point I just mentioned about being tightly coupled with different things. As an example, as like the models have changed to like be more complicated, like mixture of experts. If you don't have your infrastructure right for RL, it's just like very hard to get things working. So those are kind of like the unsexy things, which are just not emphasized, but they're just like absolutely like critical path work in like a frontier lab.
That's really helpful. Okay, let's talk about environments. You mentioned them previously. Can't walk down the street in San Francisco or make it 10 minutes on this podcast without talking about environments, it feels like these days. What do you think about the importance of environment creation for scaling RL? Would love to hear you talk about this.
Yeah, so I think probably the first thing is to define it, because I think there have been like some definitions I've seen which are like, so I think like my high level definition without going like too technical is just like, an environment is kind of like a simulation of a part of the world which you want your agent to interact with. So right now we're in this like kind of place where we kind of want to move I would say like LLMs into the agentic era, right? So we want to be able to capture like kind of real workflow tasks. So in that context, the environment is going to be simulating a part of the world, like I don't know, like maybe it's like a inbox of like a I don't know someone like a a bank or a law firm, and trying to capture real parts of their work. So it's a simulation, but the hope is it kind of generalizes to like capture like a real world task. So that's like kind of the essence of it. In practice, I would just say like it's just very, very hard to get these things right. I think the field is very, very early, and I think this is like very, very tricky. I think people underappreciate, and we saw this even in the 2010s. Like the models are very smart. So if you don't like get the right kind of detail in the environment, the agents will find a way to like cheat and kind of reward hack. So there's examples even like yesterday on Twitter. I think one of the popular software engineering tasks. An agent would go on the internet, find the answer, all this kind of stuff. So it really like requires high attention to detail. So I think that's the thing that's probably underappreciated. The second thing, and I think this is more appreciated now, is like the ideal RL environment is made by someone with like deep domain knowledge, like in the field, right? And that's certainly not like how labor is kind of working right now for these things. It's generally made by contractors. So as an example, I could probably myself like code up a very good environment for the kind of domains I've been in, like finance or sports betting or whatever. But like if you ask me to do an environment for insurance, right, I wouldn't be best placed to do it. And I think that's a general theme right now, where you almost have like the the domain expertise over here and then the RO expertise over here. And I think that's the real challenge, how you connect those two things. And it's not really clear how that kind of connects. But in principle, like, yeah, environments are very exciting. I think if you get it right and you kind of solve those hard problems, you have a chance to solve like, extremely economically valuable problems. So I'm hyped for it. But at the same time, I'm kind of like, being in the weeds of it, I'm also like, yeah, I understand it's not just a thing that, you can like just get right in kind of a week. I think it's like it's a very nascent space, and it just requires a lot of work.
Absolutely.
So that's my take on the hype.
Love it. Well, it's really helpful how you set the stage there. And one element that we hear a lot is this concept of a verifier, or the ability to verify outputs. I noticed that you haven't yet touched on that in this sort of articulation of what constitutes an environment or a simulator. Can you share a bit more about this notion of a verifier, and what do you think about the concept of quote unquote universal verifiers, which have reportedly been leveraged in recently released models like GPT?
You're right, yeah. So the missing maybe part of my previous explanation is like, okay, you can have a good simulation of a workflow, but how do you know if they've got a good outcome, right? So, some fields that might be very clear, like, I don't know if it's like a trading environment or something like that, you maybe have a clear outcome. But if I'm maybe doing like, I don't know, a legal environment, then maybe, it's a lot more of a gray area. So like verification is also like a big problem. So I think, universal verifier, like, first of all, it's like hard to say, like it's obviously like unpublished, so I can just like speculate. But I think the way I describe it is, the traditional, at least in the past 2 years, way to have verifiable rewards is that you just have like a reference answer. So it could be just a set of like maybe textbook questions and answers for math. And the model says 4, the textbook answer says 4, correct, right? So it's like very easy to like assign your reward. But as I was just saying, if it's like something like, even within math, let's imagine now you have like a proof, right? Okay, so in theory, there's a set of rules for maths which tells you, okay, this step follows from this step. But, it's not like a clear reference answer. It's easy to compare. So I think there's a general theme of now trying to get the models to kind of do this work for you, to try and like verify. So my guess would be it kind of plays into this theme. So the idea there would be, okay, even if you don't have a reference proof, maybe the model understands like the rules of math, or maybe it understands the rules of chess, right? So on that basis, it can see what it's done, and then decide how to allocate rewards appropriately. And even for a domain which is more tricky, let's say we're using legal a lot here. I'm not a lawyer, but like in that case, you might have maybe like a long form document, and you need to check if the contract is correct. Even if like it's a gray area, you could probably reason that if the model thought a long time and considered lots of trade-offs, it'd probably be a better answer, right? So the example I would give is like I'm not a physicist, but if I had to trust like a undergraduate physicist versus like a PhD physicist, I'd probably trust the PhD physicist on the question, just because they probably thought about the ins and outs like a bit more. But that could be wrong, that overthinking is a thing as well. So that's the nuance there. So I think it's interesting. The one caveat is I would say, it can get quite expensive quite quickly if now you're expecting the model to think a long time about problem, but also think a long time about verification. So I think it is like a brute force like lever. And, I might talk about this in other questions, but I still think we haven't uncovered like every kind of verifiable, domain, even within like the broader set of economically valuable tasks. I think there's still a lot to do. So my general like advice would be, if you can find like a neat reward that's verifiable, you should like go after that. But yeah, you do have these kind of new tools in the toolbox as well, which allow you to do a little bit more with these kind of more like gray area domains.
Yeah, that's super helpful. One thing that I think an insight that you had shared previously was this disaggregation between elements that are verifiable and then maybe orthogonally relative to that is the sort of compute intensity that's necessary, right? Like you could have something that's very easy to verify in terms of like how much compute you need to use in order to do so, and it's objectively like a yes or no. You could have things that are objectively yes or no, like the math proof that you mentioned, but take a lot of compute. And then on the other dimension, yeah, you have elements that are maybe more subjective and therefore just harder to verify even given infinite compute. Is this painting beautiful? Does this poetry, represent good or bad? I think that's just a really interesting way of framing the world. And indeed, the more we can identify these pockets of verifiable, economically relevant tasks, the better. And I know we'll get to that very shortly. But maybe relative to this point, in the meantime, you've I think, commented on other podcasts and other writing that you've done that much of the recent research on reasoning misses the mark with a focus that is too greatly on math and code capabilities. So in your view, what do you think folks are getting wrong, or why has the field gravitated so much there versus other areas, and where should we be placing greater emphasis going forward?
Yeah, so I think there's a nuance to this answer, because on the one hand, I think there's a lot of problems to solve with RL, and that's what gets me like up in the morning. And so when I see like another math and code paper, my natural inclination is to be like, really, guys, come on, are we still going to do this? But I don't blame academics, because I think, if you're trying to do a paper, you're going to do the kind of lowest hanging fruit where, data availability is. So it's kind of like a chicken and egg problem. But, what I would say is I think it needs to be a lot more, I would say like first principle thinking about, okay, where can we kind of use this problem within the economy and then use it, which is quite foreign to an academic. Academics want to do besides these kind of nerdy topics, but I think that's the really interesting thing. I would say even if you have to stay within these kind of nerdy spaces and code and math, there is like a lot of work to be done. The best coding environments available right now are like very like problematic in different ways. They're not kind of exactly representative of even like real world like software engineering tasks, and this is like for the area of environments which is most hyped, right? So there's still a lot of work there, but I think the challenge in academia is like, because the incentive is to like publish your work and get citations, often there's not a lot of like follow-up after you kind of had that initial release. And I think that has to be like a big culture shift in academia now, where you're not just like putting out an artifact and forgetting it. And then, as we talked about before, with things like reward hacking, this really is kind of like a living an environment is like a living thing you need to iterate on. So I think that's that. I think aside from that, like my other recommendation, I think in the general field of academia is to kind of focus on like more scientific questions, because the field in general at labs has moved a lot more towards like kind of brute force engineering, but there's still a lot of space for like good science to be done. So the example I would give is with Galactica, we found out just by like kind of raw empiricism that, okay, if we just did more epochs on the data, it gave us better results. But we didn't do a lot of hard science. But then a few months after, a good academic paper came out, which kind of took that finding and then really fleshed it out and developed scaling laws for kind of data constrained models. I can probably link afterwards in the chat. I think that's a great example as well of what you can do in academia. So kind of finding things which are kind of mentioned or like hints of things in like big lab papers, and then just doing the science to find out what's really going on. So that's my general advice. And that's like broader than reasoning, but I would say even within the space of reasoning, there's a lot of questions like to be asked. Even now, I would say, we still don't understand very fundamental questions about, could we have, got like, O3, like strawberry models with like early base models, right? We just don't know these questions. That'd be really interesting. Maybe if we pushed harder in 2020, we'd have the future a lot sooner. And I think there is space for academics to answer those kind of questions. Yeah, that's my general advice.
Really interesting. I want to take us in a slightly different direction now and talk a little bit about a more macro series of questions. We have seen remarkable progress from Chinese labs in particular in this space. So Quen, DeepSeek, Kimi. How do you assess their capabilities versus Western models? And what can we, if anything, as an industry learn from their approaches?
So I think, definitely the suite of Chinese models that are now available are, I would say, surprisingly competitive. If you probe a little beyond the kind of like baseline evals, I would say they're slightly behind. But the interesting thing is they're good enough to make progress on. So if I had enough compute and I was like heavily focused in a particular area, I could build on top of like a Quen or DeepSeek or Kimi and like get very good frontier level results. So in that sense, like it doesn't really matter if they're a little bit behind, if like someone can use them to build like meaningful work. So I think that's the first thing. I think the inspiring thing, and I just look at DeepSeek as an example for me, the thing to learn about DeepSeek is like they really, they grabbed the brass ring when it became available, and that's what really admires me about that, because I think the way to operate in a space where you have like extreme compute asymmetries, where like big players have like so much more resources than you, is you just got to move super fast and see where like the community like pulse is going to be. And there were definitely like misfires in this direction, like where maybe some players thought maybe multimodality was going to be a thing. But in my mind, it was like very clear as soon as like, O1 came out, it was very clear what the reasoning kind of direction was. And, it definitely wasn't DeepSeek's to win. And what was particularly admirable, I think, is that if you actually look at their papers, they had a very different direction in the reasoning space. They were going down like process reward models, all this kind of direction. But at least from what it seems is like, as soon as they saw that, they dropped that whole direction and went in like this kind of long chain of thought direction. And I think that requires a lot of courage, because definitely in research it's a real like sunk cost like fallacy, and there's always like a trade-off. It's like, should I just push this thing I've been working on a little bit further, or should I like say, excuse my language, like fuck it, I'll do something completely different. And that turnaround I think is really admirable now. And I think that is that's definitely a Chinese mindset, to understand what works and just like really go after it. But I think that should be a mindset for startups more broadly. I would think it's like seeing where the puck is going to be, but then being absolutely focused and going after it. I think that's a really like admirable trait. And yeah, if I'm being honest, like definitely American companies like dropped the ball on that. So I think that's like something to admire, but also be better than those guys at, I think. So that's what I take from that.
Very evocative framing. And this dovetails nicely with our next question. Something that we have been musing on that Aaron articulated earlier. With high compute RL, we may be able to expand model capabilities into domains where answers are harder or more computationally expensive to verify. And there is this notion as well of what tasks are economically valuable. That's an important dimension of this. Robotics is this great example where there is a possible to verify outputs, but maybe computationally expensive, also likely very economically valuable. Can you talk about the tasks you think are on the cusp of verification and economic value? How do you see that intersection, and what tasks might you offer as ones that are really ripe there?
Yeah, so I think definitely this new I would say kind of more general verifiers, whatever you want to call them. It definitely opens up like the possibility of RL being impactful in more fields. I think the key issue is these kind of like general verification methods are more costly, so it kind of has to be justified by like kind of the return it's getting. So I think it was always a flaw of people in the past to think, okay, reasoning models are super expensive. And people have said this in other podcasts, but the real question is no, like it's not about how much it costs, it's about what you're kind of replacing, right? And then there's definitely fields of economic work which are very expensive, like lawyers, M&A, this kind of stuff. So that's the first thing. Is like, okay, what is the value of the activity you're kind of automating? I think the second thing is reliability. Now, I think this is probably the number one thing that's underplayed. So, we saw this is kind of a separate thing, but in the 2010s, we also obviously saw self-driving cars were good, but they weren't at that level of reliability to be, I would say, economically useful until like very recently, right? So I think the real question is not even like, okay, can a general verifier do a good job of like saying whether this legal document is correct? The real question is like, is it good enough to be trusted, right? So I think that's the real question. I think, but even if we don't trust it completely, I think we're reaching like a level of generality where we should expect like a significant presence of an AI kind of in the loop of like a real like workflow. So that's what I'd say on that. I think the second point is I definitely almost like reversed the question a little bit. I think I mentioned this before, but I still think there's just a lot of, I would almost break it down to two problems for environments. Like number one, like you said, can you verify the problem? But number two, do you actually capture and simulate the right workflow? And actually what I'm seeing now, certainly in the space, is like the environments are too artificial. Like there's too much toy problems. So even in domains where it's like verifiable, like you're not really capturing the real economically valuable task. And I still think there's like a lot of low-hanging fruit there where you can actually go in, like deeply understand the domain and solve it, and maybe not, for some class of problems have to worry about the verification thing, immediately. So that's how I can frame that question.
Really helpful.
That is really helpful. I wonder if you might be able to offer some concrete examples of where you think like there are toy problems that are not representative of the real task that's relevant, and how we might be able to ultimately innovate to create simulators that are of higher fidelity and greater relevance. And maybe I'll append a question to this, which it relates to your company, General Reasoning. And I wonder, maybe through this question, you can tell us a little bit about your vision and what you're working on.
Sure, yeah. So maybe I'll get to the second bit first. Yeah, General Reasoning, a new company in London. We're still fairly stealthy. But I would say like a very high level, like our mission is just to enable like agents to work autonomously for like very like long periods of time. So right now I would say like a lot of issue with agents is they're quite lazy. They can do specific tasks, but they don't have this kind of persistence and ability to like do this like much more like open-ended tasks. And I think that's the real thing, because if you think about kind of your real world job, it's not like a nicely like specified task. It's messy. You have to like figure things out, and you have to like work on a problem for a long time. So that's like, I would say, the broad level focus. Now, in terms of like how we go about it, I mean, I think that this is a general point in the environment space, but I think there's two ways you can think about it. You can kind of be capability driven, or you can be domain driven. So capability driven means, okay, within that space of long horizon things, like, what would I like the agent to do, right? So, one problem might be, okay, maybe I want the AI to do scientific research, or maybe I want it to do like, I don't know, make a trading algorithm or something like that. So that's like a very open-ended question, but it has a lot of depth to it. And then the other aspect is more domain specific, where it's like, okay, I deeply care about this domain. I'm going to go in and like literally find like what is the best like kind of AI shaped problem, and then kind of make that into our environment. And I think those are two legitimate approaches. So that's that. Now, in terms of like, okay, what are the toy problem like kind of issues we have now? I think there's a good example of that recently. Although in theory you're seeing labs like claim like maybe 70 to 71% on these like benchmarks like SWE bench. Like there's also been like recent studies which show like I think it's like Meta who did this study, like when they actually tested like what percentage of PRs like would be accepted, it was like 0%, right? So I think that really like you can question like the legitimacy of that study, but that shows us something like fundamentally wrong with at least the evals, the environments we're making. And I think that is like the single biggest like problem right now. There's obviously like going to be less visibility on this. I think we also now know there's like a lot of spend in like RL environments and frontier labs, and these are not like public things. So of course in private the situation is like a little bit different, and we're getting a little bit more fidelity. But I think that's the number one goal. But no, broadly, yeah, long horizon capabilities. We have a number of ideas of how to get there, and yeah, we're looking to share more on that in the future. So that's that.
You piqued our interest, leave us wanting more. Well, okay, maybe to round us out, stepping back to a much broader view on this whole space of reinforcement learning and large language models. Almost a decade ago, Jan LeCun, who was once your colleague in Meta days, made waves with his layer cake analogy, with which I'm sure you're familiar. For those who aren't, Jan suggested that if intelligence were a cake, unsupervised learning would be the bulk of it. Supervised learning would be the icing, and then RL would just be the cherry on top. What do you make of this analogy? And do you think that RL is indeed the cherry on top that takes us to AGI, or however you want to define that? Or should we think of the confection as a cherry cake, where RL is more central to unlocking intelligence?
Yeah, so first of all, I love Jan. I definitely have a soft spot for Jan. After the whole Galactica drama, I think he was like kind of single-handedly like defending us from the mob. So I always have a soft spot for Jan. So I'm a little bit biased on this question. Yeah, I think the cake analogy was like deeply perceptive, and I think it's like classic Jan that he, probably would be regarded as an LLM skeptic right now, but then had like the vision to see at least how the early wave of LLMs would go. So, the vision being that, on the one hand, you have the bulk of the cake, like you said, which is going to be, all this like data about the world, not necessarily just text, but like just like a lot of world knowledge, having this like kind of thin layer to try and get the agent to do the right thing, or sorry, the LLM to do the right thing, and then the little bit of like data for reinforcement learning. I think that very well describes at least the situation before 2023. I think as you kind of hinted at, what's changed now, especially with the reasoning paradigm, we kind of moved away from RLHF, which is kind of more human preferences and had limitations for reward models, towards these kind of more at least verifiable or maybe now even like machine-driven rewards. And that's just led to a lot better results. So whereas before you'd maybe be bottlenecked by like your kind of highest taste, like, human annotator. Now in principle, for some domains, you can kind of go like much beyond, human performance. So, what you're seeing now is this kind of, mission inflation from AGI to superintelligence is like highly, like, I would say downstream of this kind of like hype about RL. So yeah, the picture kind of that's been pictured, promoted now is kind of the cherry becoming a lot bigger and the cake, becoming very, very small. It's kind of like, skyscraper size like cherry, which is a kind of a very intimidating image. I think that the one thing I would say that kind of underestimates is just like we are going to need humans in the picture, at least in the short term. If I want to, like we were saying, make a high fidelity environment, right? The models are very smart, but they don't have everything. Like most of this kind of domain knowledge, workflow knowledge, it's not in pre-training data. It's like, in someone's head, or it's deep within some like company's like internal data, which isn't in the pre-training data, right? So yeah, we need humans to solve that problem. We need humans to specify what, the reward like looks like, right? For some domain, like what is a good outcome? Again, I think models can help, but they're not there yet. And then, as we're saying, like we're at a stage where reliability isn't there yet. So you're going to need like humans in the loop as well. So, maybe I'm not sure if it's a more scary image, but I would almost have like a New York style Atlas like figure holding up this cherry, which is a human for now. And I think that human will eventually go, but I think for the meantime, we're good.
I love that. It's like I don't know if you've been to New York City, there's the Rock Center Atlas.
That's the one I'm thinking of. Yeah,
That's the one you're thinking of.
Exactly, yeah.
It's awesome. Very, very evocative. Well, I think we can call it there on that enduring image. Ross, thank you so much for joining us today. Thank you for sharing your insights on the realities and the future of reasoning in RL. This has been a lot of fun. We promise fun. I hope it has fulfilled the fun. And to our listeners, we encourage you to follow along with Ross as he builds the next generation of RL systems at General Reasoning. Hopefully we'll have more to share there in the future. And thank you for listening to Radical Talks. We'll be back soon with another conversation at the frontier of AI innovation. If you like what you hear, please be sure to subscribe and rate us, and we'll catch you next time.